Welcome to Innovation by Design, a podcast that explores how design thinking drives innovation across the AEC industries. I'm Evan Troxel, and once again, and as always, joined by my co-host, Candace Kitchen. How you doing, Candace?
Doing well. Glad to be here. Thanks, Evan. Today, we are joined by David Manns. David leads AECtech at Thornton Tomasetti's core studio, where he's focused on how technology is reshaping the built environment. He also runs the AECtech conference, builds grasshopper tools a lot of designers use every day, and has spent years at Grimshaw Architects working on projects like the Dubai Expo 2020 Sustainability Pavilion. So, David, if you could just start out by telling us a little bit about yourself. Where did you start?
First, thank you so much for having me on the podcast. Really a pleasure to be here. I started, I would say, actually in undergraduate at Pratt Institute when I came out of the Midwest and kind of into New York for the first time. And I was very fortunate when I got there to be at a moment where the current dean of RPI, Evan Douglas, was coming in as the chair and was bringing a lot of the kind of people from Columbia and other schools who were kind of beginning to push the envelopes of kind of innovation and technology. So, before scripting was a thing, was kind of beginning to learn about it and, got in on the ground floor. And at that time, we also were blessed enough to be invited to the first Smart Geometry conference when it was originally around generative components. So early on, I was kind of in the conference space and kind of seeing what people in industry were doing while being in school. After that, I kind of went out to a couple different firms. I was at Woods Bagot for quite a long time and had the opportunity to work with some great people, including Shane Berger there. So got a really wonderful kind of introduction to the culture and the growth in the professional side around the kind of technology, innovation, and experimentation. And about that time started developing tools that ultimately the first one kind of became Bumblebee, my first Grasshopper plugin that I put out there. So always had this idea of like, so many people were so generous and, inviting me into the spaces. If I'm making something, give it back. And after going to Grimshaw and working on some really fantastic projects, started to become very interested in how all these new technologies were coming into place to kind of change the way practice works. So, for example, on the sustainability pavilion, it was one of the first times we had really used VR in a project to kind of bring a client into the space and make decisions that would have taken weeks and back and forth could be done almost instantly by experiencing it. And it was also one of our first completely parametric projects we had done from like a single point all the way out to interoperability at Revit, with Revit. And at that time, I was working with Conrad Sobin, who's gone on to run BIM-Beats. And so we were kind of doing Dynamo and Grasshopper at the same time. And he started to kind of understand how all these things could come together to deliver complex projects with small teams. I got invited to attend the AECtech conference. And when I went to my first conference there, met Rabatani and some of the people at the team and was just amazed by the hackathon experience. And actually went back to Grimshaw and did a mini version of a hackathon for students at Pratt Institute where I was teaching at the time. And it really got me interested in that culture of just bringing people together to like spread that knowledge to the new designers coming in. So when I joined Core Studio, I had the opportunity to actually help contribute to AECtech. And then kind of as time went on and the event began to grow, eventually kind of stepped into a role of helping to coordinate what it is now, which is a multi-time a year event, including our New York conference, but now up to 5 events a year at this point.
So you said a bunch of terms in there that I don't know for sure that the audience of this podcast is going to be familiar with, but I don't want to just kind of go back and define what those terms are. We'll do that throughout the conversation, I think. I mean, terms like computation, parametric, all the thing you listed off, Dynamo, a bunch of tools that do that kind of stuff. Starting off even with some tools that maybe are no longer around anymore. Mm-hmm. So what did you go to school for, David, when you were at Pratt?
Sure. I went for undergraduate architecture. Okay. So just stepping into, in the beginning, the traditional architectural education and very quickly kind of deviated from that into discovering what these new tools could do.
And these tools are really based around creating geometry through kind of logic, and you mentioned scripting and what people now refer to as computational design and things like that. But can you kind of talk about like that? I don't know, it's like a specialty, but it's also, it's a way of thinking, right? It's an approach. And so I'm curious what interested you about that, because you said you deviated from like quote unquote traditional kind of, method, the way people get into the profession of architecture through, and what, maybe you even want to define what a standard approach to getting into architecture would be versus the path that you chose.
It's a really interesting question. And actually the phrase parametric design and computation design, I always kind of find funny because they somewhat emerged during that time I was going through school. And so there's a lot of back and forth. And what I've always related it to is in a, traditional architectural design, there is design intent, there are means and deliveries, tools that up until, kind of the advent of coding and scripting were a kind of given set. So CAD and illustrative programs being extensions of maybe traditional hand drawing methods, bringing in better ways to do it. And, means of kind of capturing that entire history and recreating the process by hand in a digital environment, maybe with better ways and new approaches to it, but very much grounded in that building it up. And what I thought was really interesting about what I was seeing in the, let's just call it parametric design space at that time, was the opportunity for discovery, that you could generate unexpected things, basically set up rule sets or set up processes and workflows or procedural thinking. To me, it was kind of the big thing of it. How do I distill this down into a set of operations? And if I hit go with 100 different combinations, how many things can I be surprised about that I never thought about before? And that was really a turning point for me, and my interest in it was, I can surprise myself with something, when I'm trying to come up with a creative concept, I can make the rules and let a system run and then come back in and begin to build off what was in there. And Pratt in particular at that time had a really strong foundation, and still does, around explorations in geometry and geometric relationships. There's a department there, the morphology department, that is specifically around exploring these things. And it was one of those kind of confluences where that coming together with this new technology was, if we can play with every possible combination of this geometry, what could we discover, and maybe what could that do, which was very exciting at the time.
I want to say, like, there's this idea of kind of a beginner's mindset, but it's not just a beginner's mindset in this context, right? Because what you're saying is, like, you can determine some kind of logic, like this operational steps of kind of codifying a program, basically, to run with your inputs that you've decided, and seeing what comes out the other end of that, right? So there's this kind of like unknown when you're doing this, but there's also, you're applying this. It's a very interesting kind of way to approach design. And to me, it reminds me a lot of kind of how AI works nowadays, right? Yes. It's like you throw something over the fence and you're just not sure what's going to come back. And something might come back that would surprise you, right? That's like, I never thought of it that way. To me, it's like when IBM was developing these supercomputers to play chess and to play Go, and the way that those computers attacked those problems of winning a game were unconventional in the way that, compared to how humans had approached the game. And it's like, I didn't see that coming. And I think there's some aspect of that in AI and these kind of early and continuing studies in computational design, where it's like you're applying logic, and yet you still might come out with an unexpected result, which is kind of a fun side effect, or maybe it's the main effect of doing this kind of stuff. But I mean, one of the other reasons you said, you mentioned off the cuff, you mentioned the word better. Like when you said CAD was better, I think that's subjective, but it depends on how you're thinking about it. I think when you think about it, and so I'm putting myself into your brain right now. It's like, well, yeah, there are better things about CAD versus hand drawing when it comes to drawing the same drawing. If you compare apples to apples, it's like, well, you get the same drawing. But with CAD, it's distributable digitally. It's editable, right? So you don't have to redraw the whole thing if you wanted to make a change, minus erasing and all those kinds of things. But it is, on some level, it's more editable, and so there are better aspects to it. And so when you apply that to like computational design, you design a workflow, an algorithm, something like that, and you can make one change in one piece of that. So kind of explaining how Grasshopper works, right? You're stringing a bunch of components together that's kind of like an equation. It's like first this, then do this to it, then do this to it, then do this to it, and it comes out at the end. But if you go back and change a parameter, which is where the idea of parametric design comes in, the whole thing updates at the end, and it's in real time, right? And so it just kind of spits out this new or potentially numerous number of outputs, which is really interesting. I imagine like as a student, it's like, whoa, you go into an architecture program thinking I'm going to be an architect and I'm going to draw drawings and I'm going to work on buildings. And then you just saw this, and just talk about how that impacted you as a person, and maybe how that kind of changed your view of what an architect could even be.
Oh, both of those. And to come back to the term better, I should certainly be careful with that, because I
qualify that.
I absolutely, agree that, I equate it to like BEM as well. BEM has brought like tremendous benefits, but also a lot of additional complexity that may or may not be needed, and so each one of these is certainly a trade-off. And I would say the same thing with computational design. For a while, there was a problem maybe of sameness to it, that everyone was learning the same workflows and what was available at the time. So things had a certain look everyone was inspired from, but that was kind of the learning curve of getting into it. I think it was particularly transformational for me in that it was an area I had never considered to be possible. And it's also something where I've always had an interest in trying to create something new. I was one of those students who wasn't really interested in recreating the precedent project. Once I kind of understood it, I was somewhat done, because I learned the lesson and moved forward. And what excited me about this possibility was that it was so new, and there was kind of an opportunity to be the first person to do something, or see the person doing something for the first time. And that idea of just a brand new door being opened up to an entire set of possibilities. I probably never imagined the degree to which, leading from, let's call it the mixture of parametric design, BIM, and now into AI, how potentially transformational it actually would be long term. But what kind of caught my eye at the time was I didn't understand how things were being done, even though I could be told how the rules worked, and I could maybe understand the most basic parts of it. The fact that you could do these combinations of these systems and have these layered up set of dependencies in a project, and by making those small changes early on have such drastic impact, it just really got me excited to start learning again. I always joke with a colleague of mine, because I've written some geometry plugins now, that I probably failed every math class in high school. I was terrible at it because I discovered later on I didn't have an application yet. And the minute there was kind of this opportunity to do something with it and create something with it, suddenly it was just, off to the races to learn all this. And for me, I'd say that was kind of the biggest transformation it brought. Was it just opened up a whole new potential of things to learn that you could immediately see results from and understand if you're doing it right, if it was something new. And it was just very exciting in that way. And then ultimately what it could bring to projects later is kind of, the beneficial, I think, pushback of actual production and, getting into a firm and working with it, is these more abstract problems now had concrete things that needed to be resolved, and beginning to figure out how you could map a particular workflow that maybe you did in school just to make an interesting looking image now to something where it's like, I need to make all of these panels on a facade line up and fit, or we need to actually make sure this thing can stand up with input from engineers coming in quickly. So how do we make it very responsive and quick? And it just had opened for every problem 5 different potential ways to approach it. So it was just a game of trying out 3 or 4 until you found the one that worked.
I would love to hear more about the conferences that you host multiple times a year. What's happening at these conferences? Why should someone come? What are they learning?
Sure. So AECtech started in 2013, well before my time, and was kind of inspired by a few members of the Core Studio team who had attended a hackathon and thought, this is a great idea for AEC. Let's bring people in. And it went through evolutions over the years of kind of the format, how strict we were with the rules, how structured things were. And the longer it went on, the more we found out if we just got a bunch of enthusiastic people together who all knew the problems they wanted to tackle or had great ideas, and then you let people in who have never touched code before. And then you let in people who are industry veterans and like know this problem in every way it's been resolved, that like those people will get together, they'll support each other, and they'll just make, incredible technology over the span of 24 hours. And that other part of like putting that constraint on there of basically one day to solve a problem, I think helps so much because it leans down all the possible things you could do to like, okay, we can probably resolve one or two critical things and figure out what those are. So the hackathon portion has always kind of been, I would say, at the center of the events. And since then, we've grown into hosting a symposium and workshops. And the workshop have always been this kind of not something geared towards in support of the symposium or around a particular topic, but like, what are the really exciting, interesting things being done today that are maybe brand new or just help to complete a complex project, or a startup that has something, they want to start showing and it's maybe the first conference to come to. That gets me really excited because it's like, let's introduce the world as much as we can to these folks. And the same thing with our kind of symposium models and the conversations. It's always beginning to look at, I always say like, we can't just do AI these days, even though it comes up so much. It's what are the things that are happening that aren't just changing the technology, but actually impacting the culture. We had a wonderful panel. Evan, you actually moderated at the last symposium between people that kind of started where maybe I did in kind of the implementation phase of, doing computational design on project work, who are now in senior leadership roles in companies and now can begin to think about how maintaining that culture inside of those companies can bring long-term benefit to the firms themselves. And it was a conversation I thought was really interesting because it was looking at it more of a career and a trajectory for keeping people in AEC with these capabilities and giving them a space to explore and grow and pursue their interests, but also with a mind towards the construction of projects and the architectural, buildings in the end, which is really what it's all about.
I think you're pointing out kind of an interesting conundrum that architecture in the recent past, let's just say, has found itself in, which is, people like yourself who go into the industry wanting to become architects and designers, project managers, whatever. There's many different pathways within the profession of architecture. But because of the technical proclivity of those individuals and there not being a defined space for those people to progress in their career as architects, they end up looking elsewhere. And so what you're talking about is now saying, well, there is a path from being a technology passionate enthusiast, however you want to describe that, somebody who creates tools to solve problems inside of, that it could be geometry, it could be a workflow, it could be any number of ways you could apply that. But to actually say there's leaders now in architecture who have done that path. And that is now a model for lots of other people, where before that was hard to find, right? It was definitely something that people had to seek and build a network around because, again, traditionally architecture, there was only a few paths that schools actually trained people for, which was design, project management, or technical kind of things. And this is like outside of that. I mean, when I say technical, I don't mean computer programming, and I don't mean BIM, and I don't mean geometry. I mean, they're detailing projects from a technical standpoint. Maybe they're waterproofing or doing specialty curtain wall applications or whatever it is inside of a traditional architecture firm. So I agree with you. Like it was a really enlightening conversation to have in public because this isn't the kind of conversation you can find in public. And to get back to Candace's question about the AECtech conferences, you guys are doing a service to the whole industry by putting these on, right? And organizing those kinds of things to happen and then recording them. I mean, obviously it's an in-person event that you're doing 5 times a year where some people can show up, but then recording it, putting it out there to the rest of the industry is a huge service. And I bet you've seen some other really incredible stuff unfold at these different events that you're doing. Could you maybe mention some things that have really stood out to you that strike you as kind of innovating in the space of AEC tech conferences, people getting together in person and participating in hackathons versus just going to conferences and consuming information?
Yeah, and maybe to lead into that a little bit, part of the reason we ended up doing multiple conferences a year is because thankfully the New York event grew to such a scale that we kind of realized it's important for the hackathon to be somewhat intimate, somewhat kind of loose and hacky. Never wanted it to feel too polished in a way because you want everyone to be comfortable. So we realized we couldn't grow it anymore, but maybe instead what we can do is begin to take it out multiple times a year. And what I think has been really interesting is what came out of that was, our original thought was, West Coast, U.S. hackathon, which we're still doing. And maybe we'll look at, potentially one other United States. But the thought had come up like, why don't we go to Barcelona? Or why don't we go to UK? And these would come out of conversations with people at other conferences who were like, it'd be great to have you here. What can we do, to bring it over? And what it kind of made me realize is like, there is a hunger for this in a lot of different regions. And by beginning to bring it out, what you also get a completely new set of problems being looked at. So every region kind of has a different concern or a different direction, oftentimes tied to the type of academy coming out of there and where people are kind of learning, but also the presence of firms. So, the one I always kind of point to as being, to me, the most, certainly biased on this, but the most interesting project to come out of a hackathon was years ago, McNeil, who makes Rhino, who have been great partners with the event over the year and always supported it. They had just released this new platform called Rhino Compute, which was basically just an instance of Rhino that you could access on the web, which was a radically interesting idea. And
for those who don't know, Rhino is a 3D modeling application that a lot of architects use, but you could use it for just about anything. I think it really got its roots in marine, like they were doing nautical design, boat hull design, things like that. And then jewelry designers found it and they were doing stuff with it. So Rhino is what you would consider maybe a general purpose modeling application. It just happens to be called rhinoceros. and it's kind of spawned this whole ecosystem of animal and insect named, like you mentioned earlier, honeybee, right? Like that's a tool that works alongside or within Rhino. And so just for those who are wondering, I've never heard of Rhino before. I just wanted to give a little additional context there.
I'm always very deep in the technical weeds, so yeah. I step back. They had kind of brought this idea to us and then to the hackathon, and a few people from our team and also folks from other I believe mostly architecture companies at the time had the idea, why don't we take Grasshopper, which is their kind of parametric and visual programming plugin that's built on top of Rhino that basically lets you get into coding and these kind of parametric design operations with like a very low boundary to entry. If we can host that up on the web, then potentially we give people the ability to use geometry creation operations, all the power that this tool has brought to that platform, accessible from a phone or accessible from a website, or running in our interest at the time. We were kind of getting into machine learning. We could run thousands of instances and build data sets for training ML models in the background. And it was just kind of this wild idea, but in the span of 24 hours, they kind of put together the first prototype of it that worked, and then ultimately led to this. And now that kind of platform that McNeil has spent a lot of time redeveloping and making more than a hack, but very stable and useful, is kind of the engine behind a lot of online configurators for product and jewelry, architectural configurators for kind of showing building alternate designs, and then also for kind of where we're arriving at today, and kind of the new things that are beginning to happen with hackathons that really amaze me now is how quickly it's evolved from people developing maybe foundational kind of first attempts at technology like that to, in the span of 24 hours, being able to hook up agents to MCP protocols, which call into these compute environments, and from a few words and a text prompt, returning 3D models and metrics and data. And it's kind of been this 5 to 6 year curve of all these foundational pieces of this new space suddenly coming together. And the evolution in the hackathons has kind of been from people maybe really needing to learn coding languages to get into it to now just starting to understand the ecosystem of what's available out there and being able to essentially have close to an MVP for a product at the end of 24 hours that really brings industry value or even is provocative to a new direction it could go. Our most recent London event, we had a team that wanted to look at the idea of, before going to consultants on a project to talk about the different parts of the project, basically having agents that would represent the interests of each one of those consultants and actually essentially fight it out in a virtual room about what was the most important thing and kind of have those conversations and find balance a little bit before. And I thought it was really interesting because behind the scenes, it's leveraging all this technology and it's, all these different systems and protocols being brought together. But the end user experience was this very human thing of like an image of 3 people around a table with word bubbles, reflecting their thoughts. And it's like, oh, I don't need to know anything about technology to use this, but immediately I can see the value. And that has been a really fascinating emergence recently coming out of it.
I think that's wonderful to see all of that. And you helped to create over 20 plugins, right, for Grasshopper. Do you have a favorite?
I do. I shouldn't have a favorite child, but I do. Mesh
we all do, David. You're not supposed to say it, but you do.
Luckily, I only have one actual son, so he is the favorite.
That makes it easy.
Yes. I made I think it was my second plugin called Mesh Plus, which is a geometric and kind of mesh subdivision plugin. And it's the favorite one I've made because it's every time I work on it, and I'm still working on it today, it's just a constant mechanism for learning. I'm always learning new things, delving into new white papers. It also happens to be like the most popular one I've made, probably because it's one of the oldest ones, but it is something that I enjoy working on. What has surprised me though is I kind of made, I don't want to call them throwaway plugins, but a few ones that were like, let's just build this really quick, lightweight thing to like export a PDF from Grasshopper or make a Word document or a PowerPoint. That was like just something we needed at the time. It's like, oh, I'll spend a week and actually flush it out into a real plugin. And like, those are the ones that I hear back the most from people now that are actually using it. Cause it's like, oh, it saved me, X number of hours making thousands of pages of this. And the deeper we've gotten into technology at Core Studio, the more those types of tools have become really important, because at the end of the day, our engineers or our clients still want a PDF. They want that simple, clean, distilled answer in addition to the environment that they're modeling in. And those little types of tools and putting it out there, I think it's, if it helps 10 people, then great. It was worth the time to do.
It's really cool that you make those and then make them just freely available. I think that's what's so cool about the community that you're a part of developing now, whether you meant to do that or not. I mean, you were a part of that community by electing yourself into it, by developing, but then furthering that by doing the hackathons and AECtech and really kind of building a global community around this. I'm really curious to hear your thoughts around this idea of innovation, right? Because I think innovation can be directly applied to what you just said, which is like stuff that people don't like to do. Like, let's take care of those kinds of things. when a lot of times innovation is like a shiny new thing that doesn't exist yet, is kind of how people apply the definition, or that's how they think of innovation. But to your point, like it's just solving problems that people either, maybe they don't realize that they're problems. They just don't realize they're spending a lot of time doing this kind of stuff. And then all of a sudden, okay, now it's taking care of it for you, or it's just solving a pain point that people have. Thoughts around that, the idea, the definition of innovation and what that could mean in different ways?
Thornton Tomasetti has a slogan, which is to be the driving force in innovation. And what I've always thought about AECtech in relation to that is, I don't think AECtech and Core Studio is trying to be the driver of change in that space. More that we're trying to open up a space for people to come in and push the innovation on their own. Very rarely do we come in with an idea. Even in our symposiums, we stopped doing themes years ago because it was like, let's not push anything on people. Let's let them come in with what their interests are. And something always emerges every year from that. To the hackathon side of that, which is where I think a lot of maybe the thoughts and the kind of innovation that actually comes from the conversations being had at the symposiums, or the new things being learned at the workshops, kind of culminate and come together in this. What I find interesting about that is a lot of the struggle, I think, from beginning to try to push innovation without being an end user of the actual thing you're trying to create, is that you end up creating technology that is maybe really radical and new, but not actually useful in a way, or it's something that's completely mismapped to the way people really work. And the kind of nice thing about the hackathon format that we kind of curate and put forward is keeping teams a certain size so that the people coming in with maybe the problem they need to solve get as much space to kind of come up with a creative solution for that as someone who's looking to create the next compute, or create the next Rhino MCP, or a really advanced piece of software. And I always laugh because at least every 2 or 3 hackathons, something about timesheets comes up and wanting to use AI, and no one ever does it. But one of these days, someone's going to do it, and that's going to be the biggest thing to ever come out of one of our hackathons, because it is just one of those things that it's not in service of what you're trying to do as a professional. It's something you have to do to track it, and it's not something that's pushing the industry forward. It is literally just work. It's not craft, it's not creativity, it's not problem solving. It is just work.
There's creativity in timesheets, I guarantee you.
Not in mine, I promise. No, but
it's a work of fiction.
I think that's really important, though, is as much as you can reduce the work and open up this space for people to get to the things they're really interested in. I think that's important. It is also a concern I have with the emphasis on automation, though, which is a big one in innovation as well, is I kind of recognize the importance of a little bit of downtime in work. And sometimes those repetitious tasks are where the thinking happens. And I do worry if we are trying to just constantly be, innovative and at the peak of everything we're doing, it's maybe not leaving enough time for reflection about what's really being done. And I've seen some really tremendous presentations at hackathons lately, symposiums lately, that have been looking back at the idea of like, what is the real value of the practice of architecture or of engineering, starting to, particularly as AI is creeping into the mechanisms of how we actually deliver stuff or do things, figuring out what it is we really think we want to be bringing to it. And I think that takes a little time, stepping back and not being so deeply into the process that you kind of maybe lose a little bit of why we're doing what it is we do.
I think the importance of reflection is huge. You think about just stepping away from something, even if it's, a project you're working on your computer, and you're like, all right, I'll tackle it tomorrow, or I'll tackle it in 3 hours, or I'll switch the next task. It's so important. You have to clear your head a little bit. So I love that, people are listening to a symposium, coming to the next one, which speaks volumes, I think, that they're coming to multiple a year potentially. And then reflecting on something that they learned or were thinking about.
And it is also, I think, a benefit of the hackathon model in particular is it brings a lot of people in, a good percentage who aren't actually from architecture, engineering, or construction, or from software development or other design industries, apparel and industrial, automotive, graphic. And they bring in their workflows and their ways of doing things. When I was at Grimshaw, I had spent a little bit of time before that in kind of the software development space and just learned simple things like agile workflows and Kanban and like these kind of different principles of working, which weren't in the traditional kind of architectural workflow, but made something like the Expo project possible because of that exact reason. I would just have a whole list of tasks that needed to be done. And based on, how much juice there was left in the battery for that day, could still get a few more done or, be ready to prioritize the critical one. But it was kind of leveraging technology to just lay out the parts of the project in a way that team members could come in and grab what they were ready to do at the time, because that's what they had the most energy for at that moment. And it proved to be very effective, but it was something that just came from, the software development world and not at all something you would learn in a traditional architectural background.
So I want to do what you just talked about, David. Yet perfect segue here, which is like this stepping back. I'm curious from your point of view, because one of the things that I see hackathons kind of facilitating is this bringing together people without expertise or with a different kind of expertise. Like everybody's going to come to an event with a different set of experiences, expertise, etc. And you're basically allowing them to kind of self-form a team around an idea, and kind of people are kind of voting for ideas and like pitching ideas that other people can get excited about. And then they're all going to take 24 hours to work on that idea. And then they present it at the end, and there's voting, and it's fun. And it's like this community event. This kind of self-reflection angle that I want to take at this is because this applies more than just to engineering firms or architecture firms and technology users. I think this idea of what you have achieved with putting on a quote unquote hackathon, I think it applies to other businesses and other industries too, or it could if people wanted it to. And so for you guys, for Core Studio, for Thornton Tomasetti as an engineering firm, I bet you get so much out of these because you've taken on the responsibility of putting them on, but you participate in all of them, which is probably the more key factor here, which is just continual, like you're investing in these, but you're also getting so much out of them. And so you could be a building product manufacturer, you could be a code council, you could be an industry organization, and you could hold a hackathon. And so I'm just curious if you could share, like what do you guys get out of this? Because again, you're investing a little bit, but I bet the rewards are way bigger than the investment.
That's a really good question, and one I get almost all the time is how does TT keep supporting this to a certain extent, or maybe why is a better way to put it. Certainly the exposure to ideas and the kind of forefront of innovation, new things being tested, new approaches to tackling things is really beneficial to kind of give Thornton Tomasetti a sense of what is possible and what we can begin to look at, kind of investing in what do we develop. But I also think it's a little bit of a guidepost of areas where it's an industry has already solved this, or someone else has a great solution to this. So rather than reinventing that particular way of doing things, we can look at that existing model. I also think it's a really good check for where the health of the development of one particular area of AEC is at a given time. If someone is like really coming into the hackathon, it means they've got problems they want to solve, whether that's someone from the company being like, let's send 5 people, there, or it's people from that company being like, I really want to figure this out. You can kind of see where the energy is and therefore kind of understand where maybe the strain or the potential is as well. We certainly get a lot of exposure to the technology for, what is available, maybe new things we can use, learning about, I keep coming back to MCPs because it was one that I was at a hackathon and I had never seen the phrase before, probably because I was too busy preparing for the hackathon to pay attention to LinkedIn. But, I was like, what is this? And then I saw the hackathon project that uses like, oh, this is a new thing. And of course, a couple of people on our team already knew about it, but it was like, we should probably look into this and see what we can do. That from the kind of practical side, I think is interesting. The broader side, though, and it's something I will certainly attribute to Robert Tani and other people kind of before I came to Core, was the early exposure to the hackathons inspired what was like really possible maybe 5 to 10 years down the road. And so for a group like Core that is trying to look at innovation and try things out maybe before they're ready, it was kind of a big signal, I think, that at that time, machine learning was something we should really look into because we were seeing what people were doing with it and solving kind of discrete problems, and began to try to map that to all the different parts of designing and engineering elements within a building. So it kind of kicked off this effort. And, I always show a little animated GIF of us running this thing with like click macros on our PCs at night because we had no idea how to make synthetic data at the time. And it was the best we could do. And it was completely wrong, but we were a couple of years ahead making the mistakes. So by the time the technology kind of matured up to making it possible, we had a much better idea of what we should be doing and how we should be approaching it. And it kind of stumbled through a lot of the mistakes early on. We see that a lot with kind of the agentic workflows these days, very deeply looking into that type of work, making a lot of mistakes and, really unsure what we're going to do with it yet, but really kind of understanding like this bringing everything together is going to be tremendously powerful. And that kind of window into seeing what people are interested in and then going, that's what we should be looking into, because we're not necessarily looking to make a product, but we're trying to identify where other parts of the firm may want to be investing, real time into in the future.
Very cool. Well, I appreciate you taking the time to talk to us today. I think there's a lot of really interesting insight in here. Something you mentioned in that last piece was people coming to these looking to solve their own problems. And I think that is such an amazing proactive attitude to have, that you're facilitating that to happen, because there's also a huge group of people out there just looking for the right software to buy, right? Or hoping that it exists. You're actually talking about people who are just getting their hands dirty and trying things out. Failures a lot of times, success sometimes, but they're the ones who are rolling up their sleeves and getting their hands dirty and actually trying to solve these problems for themselves. And what's amazing is how far the tools have come to enable people to do that. And like you said, you don't have to be a coding expert anymore. You can have good ideas and you can use these amazing new tools to really help you get there, or part of the way there, but then bringing together these teams of people and using that combined experience to solve problems, I think is the biggest takeaway about the possibility of hackathons and people showing up excited about solving problems. It really kind of goes back to that architecture and engineering mindset that like you're up for the challenge. And that to me is what is one of the coolest things about this industry is it's full of people who want to solve problems. And
Yes.
It doesn't have to be a building. The answer doesn't have to be a building. It could be so many different things. And it's really cool that you guys are investing in the facilitation of that happening for the betterment of not just yourselves at Thornton Tomasetti and Core Studio, but the industry at large. So I appreciate you coming on the show today to talk about that.
Yeah, thank you so much. What you said was incredible. It's really cool to see people coming together, like Evan said. So,
And David, we'll have links to everything that you talked about and how people can connect with you in the show notes for this episode. You can find those in your podcast app. David, until next time, thanks.
thank you.
Thank you both.